Hello and welcome to the December 2022 Longevity Review, presented to you by the Canadian Longevity Association, a federally incorporated nonprofit whose mission is to accelerate the introduction of effective longevity treatments and to ensure their free availability to all Canadians under the provincial healthcare system. My name is Chris Linnell, and I am the founder and president of the association. We are a volunteer-run organization and are just starting out, so certainly could use your help, regardless of your skills or time availability. If you would like to help us achieve our mission, then please fill out our volunteer registration form, which you can find here, or contact us via our website, Facebook group, or on Twitter. Now, before we get started, I should say you should be able to find a link to this newsletter below the video. So if you want to take a look at it first before watching this or follow along at home, please feel free to do so. Anyway, without further ado, let us get stuck in and take a look at the highlights from December 22. Now, starting off with a lifespan study or lifespan extension study, since that is what we are all here for, wishing to extend our lives, or especially to extend our healthy lives as much as possible. And this study we're going to look at is actually a follow-up to a study which was done in 2020, in which they found that casein, which is an inhibitor of a cell regulator called CDC42, doesn't really matter, which affects cells' polarity. Anyway, the CDC42 increases with age. And they found in 2020 that when they injected older mice for only for 4 days, for consecutive days, with this casein, it improved various health parameters, reduced their epigenetic age, and perhaps most importantly, increased median lifespan by 10% and increased maximum lifespan by roughly 18%, which is certainly not to be sniffed at. Anyway, in this follow-up study, they further examined its effects, and they've figured out that it seems to really affect in a beneficial way stem cells, especially the stem cells in muscles. And in the further studies they did here, they found out that it improved endurance and muscle strength in terms of their grip force and how long they can stay on a rotating rod. They've actually got a couple of videos here if you wanted to take a look. They say movie 1, and I think there's movie 2, which we won't take a look at. But certainly the younger mice, or the mice given casein, were moving all around their cages, whereas the same age mice which didn't have casein kind of just sort of sat there, as old mice tend to do. However, what was really interesting in this study, and the reason why I placed it first on my list, is let's get down to the results here. Okay, so what they did at the sort of final part of this study is that they injected 80-week-old mice, so a year and a half old, so I'm not quite sure, maybe the equivalent of like a 6-year-old or something like that. And they gave the mice casein for 4 days. And then on the 5th day, they harvested the blood stem cells from those mice and gave them to some other older mice, which had their immune systems compromised, but regardless, they gave them to some older mice. And here are the results. So I think the The gray line is just old mice that had nothing happened to them, and they just lived their lives naturally. And then the black line is, I guess, old mice who had old stem cells, blood stem cells from other old mice, just which weren't treated in any way given to them. Whereas the blue line shows the old mice, which were given blood stem cells from old mice, but which had been treated with casein for 4 days. You can see here they lived considerably longer. And in fact, their median lifespan extension, so after 50% had died, was 25%, whereas their maximum lifespan extension was a whopping 34%, which is quite big, very big, in fact, for such studies so far. Now, so pretty exciting stuff. However, and they always need to be thrown this caveat. The numbers of mice in each group was quite small, 10, 16, or 19. 16 were the treated casein mice, so very small number of animals. However, it still reached statistical significance, but obviously it needs to be replicated with large numbers of animals. And interesting to see how this progresses, if they can do this in non-human primates and eventually hopefully move on to humans. But certainly a molecule worth keeping an eye on. Now, this sort of leads us nicely into our second paper. So even if they managed to develop this drug to humans and gave it to humans, and maybe the humans would get stronger or their muscles would improve, but how would we know that it actually could improve their lifespan? I mean, that would involve a study taking decades. And so obviously it would be time prohibitive, but also pretty cost prohibitive as well, pretty expensive study to do, which is one reason nobody's ever talking about doing a full lifespan study in humans. Now, if only there were a way to somehow short circuit that, reduce the length of time any lifespan study in humans would take. And this is where biological or epigenetic clocks come in. So epigenetic clocks, a little bit of a primer here. So the epigenome sits on top of our DNA. And it's what tells each individual cell whether or not, which genes are turned on and off. What's the difference between a neuron, brain cell, or a muscle cell, for example, because they all have the same DNA. Now, over time, those epigenetic markers change, and they change in a relatively predictable fashion, as scientists have found out. They've created these clocks which can not only tell you how old you are based on your epigenome, but also tell you whether you are aging faster or more slowly than the average person. So these clocks are being used, and the idea basically is that if these clocks can become accurate enough in terms of predicting mortality, then they could be used in human trials of longevity interventions, and hopefully, in a matter of months, or hopefully no more than a couple years, be able to say if somebody is aging more slowly or hopefully aging more slowly than people in the control group. And also, if the clock can tell you what your mortality risk is, sort of in a sense predict if everything stays the same, when you would potentially die, then hopefully they could be used in trials to show whether or not the drug is working from a longevity perspective. Anyway, that long preamble leads me on to our second study, which is basically a new improved version of GrimAge, which up to now seems to be the most accurate epigenetic clock Yes, especially when it comes to mortality risk, time to death, time to chronic heart disease or chronic heart failure. Now, GrimAge 1, which came out a few 2 or 3 years ago, I guess, has already been used in quite a number of studies. Um, and anyway, in this new study, the authors of GrimAge 1 have now released a new and improved version, which is even more accurate. So, I mean, it's still relatively early days. The first epigenetic clock was only around 10 years ago. And we still need to figure out exactly how accurate they are. But there's so much work happening in this field that within a few years, we will be certain whether or not, how accurate this GrimAge version 2 would be, for example. I mean, I won't go into the details of this study, but I thought it was worth pointing out that we might be getting quite close to a clock we can actually trust, and yeah, it'll certainly accelerate human clinical trials and hopefully accelerate the introduction of actually effective longevity treatments. So good news that GrimAge 2 is out. Okay, moving on to our next study, and this is first a senolytic study. So senolytics are drugs which remove senescent cells from our bodies. Now, senescent cells are cells which have grown dysfunctional. They kind of stop working, but sort of sit around and just send out all these inflammatory molecules and basically cause us problems. They're a bit like sort of zombie cells, as the popular press calls them. And anyway, their removal seems to produce quite a number of beneficial effects. And this study, first time I saw it, I've seen it, they have used senolytics to treat Nevis. Nevis? Is that the right name? Nevis, otherwise known as moles. So the dark spots on skins. Now, turns out moles are full of senescent cells. And by treating them, here in this case, with a combination, treating them topically, so as a sort of a skin cream, using two molecules, ABT263, which is otherwise known as navitoclax, and also another drug which affects the MCL1 pathway. Basically, the combination of these two drugs removed the senescent cells from the moles, and even more impressively, according to this study, actually removed the here it is in its topical application sufficient to eliminate nevi, so moles, in male mice. Now, unfortunately, there weren't any photos in this. Get to the bottom, yeah. In this study, the closest they have is some cross-sectional photos. So I guess the dark staining is senescent cells, and they've pretty much gone from the combination treatment here. But anyway, the thing that makes this interesting is not so much from the cosmetic point of view, but I guess that's maybe an early use for it for people who just want to get rid of any moles for cosmetic reasons. But more importantly, and this is certainly the reason why it caught my eye, is of course that melanoma, one of the deadliest form of skin cancer, arises from moles. And the idea here would be that if you could, remove moles using senolytics, then hopefully that would maybe stop melanoma arising in the first place. Now, I guess this story is close to my heart because I have a number of moles on my body, and actually after my last general, my doctor said I should have a couple removed. So I'm waiting for an appointment to have a couple of moles from my body removed, which if this skin cream was available, I would just need to use that instead of an actual surgical, well, I mean, having it, yeah, surgical operation, getting them cut out. But anyway, I thought a very novel and interesting use of senolytics here. Carrying on to our fourth study for the month. Here is, yeah, quite not maybe for the squeamish among you, but here in this study, they basically took the gut microbiota, the form of fecal samples from young 5-week-old mice and gave them to 12-month-old mice, so 1 year-old mice. And they basically found out that maybe similar to casein, the muscle fiber thickness increased and the grip strength increased, and there were beneficial effects to the skin as well. I believe the water retention of the skin improved. Now, more and more evidence is coming out about the importance of the microbiota, basically all the microbes living in and on us, especially the microbes in our digestive system. And I believe there was another study showing that there was actually lifespan extension if the microbes from young animals were given to older animals. Anyway, this is sort of further evidence about the potential beneficial effects. Now, presumably they'd, rather than actually, in the future, rather than transferring fecal samples, they might find out what are the microbes in the young animals that are performing this beneficial effect. So in the future, hopefully, we could take a probiotic supplement, just like you can already buy in the supermarket, in the yogurts, or actually in pill form, when they say, we'll give you 5 billion whatever bacteria that are used. So anyway, this is just further showing that another example of how things from sort of young animals, when given to older animals, produce beneficial effects. In this case, the microbiota, as they conclude here, our results provide solid evidence that the gut microbiota from the young improves the vitality of the aged. And there's a video there as well you can watch about it if you want to look at some cute mice. I guess if you think mice are cute, that is. Anyway, continuing on, and sticking, however, to the theme of transferring things from young animals to older animals. And however, this time it's not the microbiota, however, it is the plasma. And here they took plasma, so basically what most of our blood is made out of, but where the red blood cells swim inside, the sort of the fluid, so to speak. And when they took plasma from rats this time, 5-week-old rats, and gave it to 2-year-old rats, and they injected the plasma for 30 days, they found that it, so I didn't say that the purpose of the study was about the reproductive ability of rats, the male reproductive ability. So this was given to male rats, and they were seeing how this affected their sperm production, because in old, from, well, fairly, I guess, young age, male sperm production decreases and the quality of the sperm decreases, which of course leads to potential birth defects and difficulty conceiving later in life. So here they found that basically the young blood plasma transfer restored DNA methylation to that of the young. So again, going back to the epigenetic clocks, because, well, when the epigenetics change, it's basically a change of methylation. So again, it sort of seemed to be making them younger from that perspective, but perhaps more importantly, from a practical standpoint, um, it significantly increased. The wording here is so strange. Significantly increases the decreased. Basically, significantly increased sperm counts in the elderly animals because they decrease, and here it increased the decrease. Anyway, bad English, but so as I say, plasma transplantation may be a solution for infertility problems that occur with old age. Now, one sort of limitation of this study, they didn't actually, I guess, make the rats afterwards and see if they produced viable offspring or not, but maybe that's the next step that they could do. Regardless, another indication of how youthful factors, in this case plasma, when given to older people, is beneficial, at least for rat sperm counts. And finally, moving away from rats to an actual study in people. Yeah, so in my newsletters, I sort of I highlight and also star any study which has human involvement. And this one is all about NMN. So NMN is a increasingly popular supplement, which is an NAD precursor. Basically, it elevates levels of NAD in our bodies. Now, NAD declines with age, is used in numerous processes in our bodies, and the idea is if we could raise the levels of it, then beneficial effects would occur. And the two main precursor supplements, new ones that is, are NR-nicotinamide riboside and NMN, which stands for nicotinamide mononucleotide. Better just know it as NMN. Are, as I say, are the two sort of recent popular supplements devoted to that. Now, because they are new, they have most of the people started taking these when the results were basically only in animals. Fortunately, human study results have started to come out, and in 2022 in particular, there were, oh my gosh, I have to count, like seven or eight studies came out. And this one was quite interesting because it was, well, for a number of reasons. Well, firstly, that showed some beneficial effects. Before we get to those, I'll just say another couple reasons why this study was quite interesting. Because firstly, it was a slightly larger study. There are three groups of 80 people. No, sorry. I will take that back. 80 people were involved in this study, split into four groups of 20, and 20 were the control. But then 20 were the remaining 60. In three groups of 20 were given three different doses of NMN over the course of 60 days, and the doses were 300 milligrams, 600 milligrams, or 900 milligrams. And what they found out was that, all three doses increased the blood levels of NAD. However, it was dose dependent. So the 600 and 900 doses increased more than the 300 dose. And in terms of practical effects, it seemed to slow down the biological age based on the Aging AI 3.0 calculator, whereas the control's age increased. Actually, you can look at the figures if we get down to them. Hold on. Yeah, so here, I guess I should say, here's here the blood levels changes. So the control stayed the same. 300 level increased. The white bar is 30 days. The gray bar is 60 days. And you can see here 600 and 900 milligrams increased considerably, even over the 300 milligrams. But there wasn't much difference between the 600 and 900 milligram doses. And in terms of the biological age, yeah, you can see here that whereas the controls, it increased, increased during the course of the trial. It didn't sort of change that much, or even in the 600 groups, went a little bit down, according to this calculator, which actually involves blood work, 19 different blood parameters. So not an epigenetic clock. But here, from a practical point of view, in terms of a actual impact on quality of life, is the 6-minute walking distance test, where basically you get people on a treadmill, they walk for 6 minutes, and you measure how far they walked. And here you can see the controls. So again, white is after 30 days, gray is after 60 days. Stayed basically the same. Whereas for the 300 milligram group, it increased and continued increasing after 60 days compared to 30. Whereas both the 600 and 900 milligram group showed a quite considerable increase in walking distance. Now, but there wasn't, however, much difference between the 600 and 900 milligram groups. It was not, certainly a non-significant difference. And they also gave the participants this, what's called the SF36 questionnaire. It's basically about quality of life and how they think the quality of their lives are going. And once again, you can sort of see here that for the control placebo group, not much change, or a little bit of change. For the 300 milligram group, there's after 60 days a significant change over the placebo, but much more pronounced change here for the 600 and 900 milligram groups. But once again, not much or no difference at all between the 600 and 900 milligram groups. So basically, the significance of this study, I would say, is firstly, it's showing some benefit for NMN. It's not gonna be some magic pill, but it hopefully can show some benefit. But most importantly, starting to figure out what dosage is effective, because although the price has come down considerably in the last couple of years, it's still not the cheapest of supplements. So you don't want to waste money in that regard, or also you want to hopefully get an effective dose. And what this study seems to show, and this also ties in with a previous study over the summer, which also found that basically 600 milligrams thereabouts seems to be the best bang for your buck. Certainly, it seems 600 milligrams seems to produce significantly better results than 300 milligrams. But going beyond that to 900 milligrams doesn't seem to show any or hardly any benefit. And certainly, for the extra cost, I would say personally not worth it. Yeah, on a personal, I said I've been taking NMN for a few years now. I've upped my dose as the price has come down. And currently, I'm on 500 milligrams, and yeah, I'm kind of sticking at that. I could raise it to, based on the pills I'm taking, to 625 to be closer to this ideal one, but that would be a 25 increase in cost. And so I'm probably sticking to my 500 milligrams daily at the moment. But anyway, I'm also I should say that, as I say, finally I think there were like 3 studies came out last year So there's 7 or 8 or maybe even 9 studies came out in 22. And I'm just in the process now of doing my end of year review. So I'm looking forward to, I haven't done it yet, but taking a look at all these studies as a whole, because at the line, I don't want to speak too soon, but although it seems NMN doesn't maybe produce the same results, the same results in humans as it does in mice, it seems to produce or some benefit in humans. So, but we still need a lot more studies, a lot larger studies, and also sort of, I guess, in a couple of years' time, we'll be able to do sort of some meta-analyses of taking all the studies and putting them together and getting a much better idea of how effective NMN actually is. Okay, so those were the 6 highlighted studies from the month, but I just wanted to go through, show you a couple more. I mean, there are too many studies in my supplemental section to go through them, otherwise we'll be here for years, but a few I just wanted to show to you. And the next one is another very actionable one, a human study, and this involving exercise. Now, we all know that, or we should all know that exercise is very beneficial to us, and but it's a case of easier said than done. I find myself enjoying exercise when I do it, but then getting myself to actually do it, especially in the winter, is more challenging. But researchers have been trying to figure out, how much exercise do we need for benefits to be shown? And in this study, we'll just take a look at now. They basically gave lots of participants some activity monitors and let them see, let them lead the live, see how much activity they're doing. Also, all these people were part of the UK Biobank study, which is a huge, big 500,000 people, tracking 500,000 people, and they gave sort of wearable fitness monitors to 25,000 of non-exercisers for people who don't regularly do exercise for almost 7 years. And what they found out was people who managed to achieve a relatively few number of a few bouts of vigorous exercise, or of vigorous exercise every day, it reduced their mortality. And we're talking about short, vigorous exercise, talking about sort of 1 or 2 minutes, maybe sort of the equivalent of running to catch your bus, or carrying some heavy bags up some stairs, or sort of doing things which people don't necessarily think of exercise, but might occur during the course of a normal day. Anyway, they found out that that as little as 1.5 1-minute bouts of vigorous activity a day reduced mortality by 25%. 3 bouts of 1-minute vigorous exercise activities per day reduced it by 39%. And this seemed to increase until it sort of plateaued at 11 bouts of 1 minute's vigorous exercise, reduced mortality by 48%. Beyond that, there didn't seem to be any further reduction. And this was even more impressive when looking at cardiovascular mortality. I mean, it also reduced cancer mortality, but people had like 1.5 bouts of vigorous activity, reduced cardiovascular mortality by 33%. 3 bouts reduced it by 41%, and 11 bouts by a whopping 65%. So yeah, I mean, again, this is something that we can maybe, that old sort of saying, like, get off, like, on your journey home from work, get off one stop earlier from your bus, or instead of taking the elevator, take the stairs. It's sort of like instances like that when we can, especially if we, walk faster, or, climb the stairs vigorously, we can, sort of add these extra bouts of, very intermittent um, um, exercise, and substantially reduce or our mortality. And again, these are very actionable. So that's why I wanted to highlight that. Just, you don't need to go to the gym for 20 hours a week um, to gain a benefit. And I just, our next one I wanted to show to you, I just had to include. This was clearly in the Christmas edition of the British Medical Journal. Yeah, BMJ, British Medical Journal, as a, I want to say a joke, but an amusing study. Again, which is completely actionable. Now, I don't know if you've heard of the British comedy group Monty Python. If you don't, you really should check them out. But they had a well-known sketch called The Ministry of Funny Walks, where a comedian, John Cleese, walked a la this video, walked rather sillily. And this was the inspiration for this study, where they got other participants, well, they got the participants, as you can see, the participant on the left here, aped out, or copied the walking style, whilst wearing, I guess, a monitor to check their respiration rate and what have you. And the Christmas hat was to show it was for the Christmas edition. Anyway, you should see the whole clip. You can find it. You can find it on YouTube. Anyway, so that was the inspiration for this study, and as I say, they got participants to act out the funny walk from the sketch, and they found out that, well, you can see here, walking funnily, as they called that walk, the teabag walk, because it was a lot more inefficient than regular walking. It massively increased the energy expenditure, and you can see here on this chart. So it meant that their energy expenditure by walking less efficiently or funnily rapidly increased. So I don't know if you're linking it together with our intermittent short bursts of vigorous exercise. Again, if you're trying to lose weight, or trying to be just, increase your aerobic capacity and all that, so, or increase your energy expenditure, maybe this is a novel, an interesting technique for you to use to increase that. Anyway, you take a look at the paper yourself. I just had to include this, since I do love Monty Python. Okay, almost done here. Oh yeah, just a few more ones I wanted to show. So yeah, there's so many studies here for you to peruse at your leisure. A couple more mouse lifespan extension studies. First one was really interesting. I mean, unfortunately, they didn't say how much they'd improved lifespan, but female mice, when oh yeah, I have to get, oh, this is in a PDF. Won't even go into, I'll just tell you about it. Basically, female mice, when exposed to the odor, the smell of, sorry, I should say, old female mice, when exposed to the smell of young female mice, lived longer. they didn't live longer if they were exposed to the smell of old female mice. They didn't live longer if they were exposed to either old male or or young male mice. Um, Only young female mice. Again, this is maybe to do about young things and older animals. There was no effect in males, but yeah, again, also it says a transient exposure, so a brief exposure. Actually, let's take a look at the abstract. Why don't I forgot what's yeah, no, yeah, it doesn't unfortunately it doesn't say how much longer they live, but yeah, just quite curious result. Um, Another study here, this time in male mice which were given intermittent ketogenic diet. So that's when you basically don't eat carbs and your body has to switch to using ketones for energy by breaking down fat, basically. And they used 12-month-old male mice here, and they gave them two regimes. One where they had 3 days per week, three individual days per week, Monday, Wednesday, and Friday, where they were given the ketogenic diet, and then the other group had 2 days, two consecutive days of ketogenic diet each week. And they found out that those getting it two consecutive days per week had a 7.9 increase in median lifespan, whereas those who had a ketogenic diet 3 days, three non-consecutive days per week, showed a 13.6% increase. So yeah, I've not fully investigated ketogenic diets. They are obviously, I guess, the Atkins or more carnivore diets or high fat diets are considered, or I guess I should say low carb diets are considered ketogenic. So, but yeah, it's interesting that the first time I've seen an indication that ketogenic diets could improve lifespan. And as I say, it's only, fortunately, we only can see the abstract here, not every day, only a few days per week. So, yeah, interesting result there. And yeah, sorry, I won't go into it, but just the title alone. Soft-shelled turtle peptides extend lifespan and health span and Drosophila, which is fruit flies. Anyway, um, the things that will improve lifespan, eh? Though I only really tend to um, highlight ones which improve the lifespan in mice because they are so much closer to us genetically. Finally, I wanted to just show a couple studies, all to do with hyperbaric oxygen treatment. So, what hyperbaric oxygen treatment is that people people sit in a chamber, they breathe 100% oxygen under higher pressure than normal atmospheric pressure. And when I first started seeing studies about this a couple years ago, or a few years ago now, I thought it smelled of snake oil. It smelled of like, really? It smelled fishy to me. However, over the last few years, a number of studies have been coming out, showing the benefits and the fact that it is something that is actually available now. I just had a Google before coming online and saw that there's, you can get it done in Toronto. There's a hyperbaric oxygen clinic here. So it's something that could be done now. Anyway, I just wanted to highlight a couple studies here. One of which is that it seems to improve oocyte, probably pronouncing that wrong, quality in old mice and basically improves their fertility. So oocytes, I guess those are the eggs, I think. So yeah, basically this treatment here improved the fertility of older female mice. So this is the first time I've seen it used as a for the aspect of fertility. But also, I just wanted to finally point out here, in the review section, there's a readable review about hyperbaric oxygen therapy when it comes to tissue regeneration. And if you're interested in finding out more, it's a study to read. Anyway, I think I've probably yabbered on for long enough now. Thank you very much for watching. If you have any questions, please do not hesitate to contact me. I'm more than happy to explain anything further, and I'd love to see any comments about this broadcast, about this talk through in the comment section below. But anyway, thank you for joining me. I hope you found this useful, and until next time, when actually the next one will be me having my I'll be having my next talk through about my 2022 year in review, which I'm currently working on. So until next time, see you. Bye.